Hi, everybody. Hope everybody's doing well. All right, today we are going to start reviewing logarithms. So you will need your Chapter 11 notes. If you don't have them, then paper and pencil are fine. I'm just going to let you know we're going to skip around a little bit. I maybe would have reordered this if we were doing this together in class, but I know a lot of you already had this note packet in your hands, so I didn't want to change it. So we're going to go with it. We're going to skip around a little bit today, though. Okay, so we're going to start on page 12, and then we're going to do, I think actually it's page 14. I have 13 written down. You'll need a pencil. And then last time I had attached this power sheet document just because if we were doing it in class, you wouldn't do it by just putting it into a calculator. You kind of need to understand what a logarithm is without just putting it into the calculator. So you could just, if you don't have a printer, just make a quick one of these up for yourself. All right. So before we get into this, the whole idea behind logs and all this is kind of just like, if you're probably thinking, what is the point even? So the point of logs, it comes up when we have things like, let's say, if we had 16 equals 2 to the x power, and we wanted to figure out what x is, that one you can look at and say, oh, 2 to the fourth is 16, and say x is 4. Okay, but what if I had like 15 equals 2 to the x power? And we want a way to undo that x power. And so the variable is an exponent, and we needed a definition for the inverse of taking an exponent. And so, when we had something like, I don't know, x plus 5 equals 7, the inverse of adding was defined to be subtracting, right? That's our inverse operation for adding. When we had multiplication, the inverse is division. When we had like the sign of something, mathematicians just define the inverse of sine to be the inverse sine, okay? What mathematicians did for the inverse of something exponential is they just decided to call it a logarithm, okay? And I've done like lots of like looking up why is it called this, and mathematicians have kind of even agreed that it's sort of just a bad name and it can be really confusing for students, but everybody's used to it and they've been using it for hundreds of years, so we just stick with it. So how here we were thinking 2 to what power is 16? It is 4. That's kind of the whole idea behind a log. All right, so if we look at the top of page 12, we just look at this first little box here. So first, look this over. What do you think this is meaning? And then see if you could fill in those blanks. Okay. So when you're looking at these, when you see this power, you're thinking, okay, this means 2 to the third is 8, 2 to the fifth is 32, 3 to the second is 9, 3 to the fourth is 81, 5 to the second is 25. Okay, why didn't they call it a power instead of logarithm? They just didn't. Okay, so when we're thinking through these, we're thinking 2 to what power is 16, which would be 4. Okay, here we're thinking 6 to what power is 36, which would be 2. Here we're thinking 5 to the third power is what? Well, 5 to the third power is 125. Here we're thinking 2 to the negative first power is what? Okay, remember negative exponents mean take the reciprocal. So this means 1 over 2 to the first, or 1/2. Okay, this is 10 to what power is 1 over 1,000. Okay, well, we know 10 to the third is 1,000. And if I want it to be 1 over 1,000, then that means this should be a negative third power. So this is negative 3. Okay, this one is what to the second power is 81. So that would be 9. Oops, it should be a little base. Sorry, not so big. It should be a little 9. Okay, this is what to the fourth power is 81. So that's a 3. Okay, this one is 16 to the 3/2 power is what? So remember when we reviewed all the rational exponents, the bottom number tells you the root and the top number tells you the power. So that means the square root of 16, which is 4, and then 4 cubed, which is 64. So if for all of these, instead of writing power, you wrote log, for some reason, once people see that log, then everybody just starts getting confused. just think about it as a power instead. And I think last year, your Algebra 2 teachers kind of showed it to you as like a little loop where you start here, you take it to this power, and then this is the answer. Okay, and that works for all of these, right? 5 to the third is 125, and so on. So that's just another way to think of it. Okay, I have highlighted here on page 9 that like this here and this to do. This is something that I would like you to do for part of your homework. Okay, just this and then calculating these logs, and we're going to try to make some connections to the log properties, which you may or may not remember from last year. Okay, and I'll put this in the Google Classroom notes. Okay, so this part 1, just those 5. You can do the right side, you don't have to. And then on page 10, where it says part 2, again, just these, in this case, 4. And then in part 3, these 4. And then nothing on page 11 yet. This is where I said we're going to skip around. Sorry. We're going to go to page 13. I was right. I did want page 13. I think I wrote page 12 for the other page, and I want page 9. You guys are probably thinking, she's nuts. She's losing it. I kind of am a little bit. Okay, so I wanted to skip over that stuff because I wanted to practice a little bit more with the basics. So our definition of logarithm, if b and y are positive numbers with b not equal to 1, the logarithm of y with base b is denoted as log base b of y and is defined as the following. So if I have log base b of y equals x, that's our logarithmic form, right? If I have a base to this power is y, that's true if and only if b to the x equals y. Okay, and so how we're reading this expression here is as log base b of y. Okay, so sometimes you're asked to convert between logarithmic form and exponential form. We'll use that strategy when we're solving equations later, I think next week. Okay, so that came up before when we were solving equations in chapter 3, I think, and I say, oh, put it in exponential form or put it in logarithmic form. So that's just reviewing this. So take a look at example 1, see if you can take those equations that are in logarithmic form and put them into exponential form. Okay, so we're just kind of doing this loop. Okay, so 27 to the 1/3 power is 3. When you rewrite it, it should be true, right? That is true. 27 to 1/3 power, the cube root of 27 is 3. Okay, this one, same idea. 16 to the 1/2 power is 4. Again, that should be a true statement. All right, then let's take a look at example 2. Again, pause, give those a try, see what you come up with. We want to write them in logarithmic form. Okay, so sometimes people have a harder time going this way. If we rethink of this as b to the x equals y, and then I want to rewrite it in this log base b of y equals x form, okay, in the spot of the b, I have 2. All right, so this would be log base 2 of, in the spot of the y, I have the 1024, so log base 2 of 1024 equals our x, which in this case is 10. And if we looped around, it should get us back to what we started with. So then this one would be log base 2 of 1/8 is -3. Okay, here I put it in the parentheses just to make sure it was clear that that was the log of that whole thing. Okay, and the last thing we're going to do is we're just going to do some practice. Right, so I want you to start out by just trying those. So go ahead and pause and then try them, and then we'll go over them. Okay, so when I do these, it always helps in my head. What I'm always thinking is that loop. Okay, so I'm almost setting this up thinking, okay, there's my box, and I'm always thinking in my head, okay, 4 to whatever this power is has to be 64. So a lot of times you will see me writing something like 4 to whatever power is 64. and thinking, okay, 4 to what power is 64? This is where it might help to have your power sheet so you can look and say, okay, 4 to what power is 64? Okay, 4 to the third power. So then the answer is 3. When you write your answer, you would just say your answer is 3. Okay, your answer, it's not just to write this and then write 4 to the third is 64. The answer to this is just 3. Okay, so then this one, I'm thinking 3 to what power is 81, which would be 4. Again, I could just look on my power sheet. Okay, 3 to what power is 81, so the fourth. And this has like a bunch of copies on it because that's what I would use to copy it for you guys. Okay, now this one would be 1/4, this whole thing, to what power is 256? Okay, so that one you might be thinking, I don't know. Right, it's got a fraction. What am I going to do? It's got a fraction. Okay, so I would first start by thinking, okay, 4 to what power is 56, or 256 rather. So 4 to the fourth power is 256. But what do I have to do to a power to make it like flip, to be a reciprocal? So if I know 4 to the fourth is 256, but I want it, I've got it the 1/4 power, then this must have been, right? I want to go from a fraction to not a fraction. This must have been a -4. So this would be -4. Okay, because if I had 1/4 to the -4th power, remember the 4 would take it to the fourth power, make it 256. The negative would flip it, right? So this would make it go to be 1/256 to the negative first. And then, sorry, you can't see me, I'm in the way. See it, I'm in the way. And then the -1 would flip it. All right, let's look at the bottom row here. All right, you might be thinking, oh man, there's this decimal. I don't know what to do with that. It might be helpful to think of that as a fraction. Okay, so if you were reading that number, you would say it's 1/1000th. So it's 1/1000. So you're thinking 10 to what power is 1/1000? Okay, so to get from 10 to 1000, I would take it to the third, and then to flip it, I would have a -1. So this would be to the -1st power. So the answer here is -1. All right, so this next one, we're thinking 64 to what power is 2? All right, so I don't know, 64, I don't have anything on the sheet, 64 to some power to get to 2. So I would kind of think the other way. 2 to what power is 64? Okay, so 2 to the 6th is 64, but I'm starting with the 64 and I want to get to the 2. So you kind of want to think about it. What root could I do to my 64 to turn it into a 2? Right? So I know 2 to the 6th is 64. If I want to go the other way to get to the 2, I need to take the 6th root of 64 to get to 2. So if I'm trying to get from like a bigger number to a smaller number, and I'm not talking with fractions, I know here, I also went from a bigger number to a smaller number. But in this type of case where you're not dealing with a fraction, you want to think roots. So this would be the 1/6 power because I want to take the 6th root. So this would be 1/6. Did you hear that? My kids are in the room next door. They're supposed to be going to bed. They're nuts. All right, here. This would be 36 to what power is 6? So here's another place where I'm going from this bigger number to this smaller number. And so I want to think root instead of power. So I would start by thinking, okay, 6 to what power is 36? Right, 6 to the second is 36. So then that means that 36 to the 1/2 power would be 6. So then this is 1/2. Okay, so again, for next time, you're going to do those little sections that I had highlighted, and I will also put that in Google Classroom in case you're not remembering what I mentioned a few minutes ago. So that's where we're going to start, just the basics, the writing in exponential and logarithmic form and just evaluating. And then we'll talk about the properties and we'll talk about graphing and we'll talk about solving equations. I hope everybody's doing well. I have to get out of here.